Hello and welcome to my Tech Fun. I'm Igor, and a few months ago I had an experiment where I was testing optimal 3D printing position for bolts. And the result was that a horizontally printed bolt is much stronger compared to the vertically printed bolt, but unfortunately in that case we need supports. And then I got a lot of useful comments too. One of them said that split the bolt in half, so to print two halves, and then I don't even have to glue them together because the nut will hold those two pieces together. And then somebody wrote that to slice the bolt near the minor diameter, and then in that case I will have a flat surface for printing. And I had another similar suggestion to have two slicing surfaces, and in that case the load will be symmetrical in case of pure pulling force. So this means I will have three types of the bolts for this experiment printed in horizontal without supports, but also I will print them in vertical position and in horizontal position with the supports just for reference. And I will do the same with the M10, M8 and M6 bolts. And size I have three types of the test: the torque test, the pull or tensile test, and the shear stress. This means I have to break 45 test specimens. So this will be a long test for me, but I will try to keep the video short as much as possible. But you have the content, so you can jump to the result part if you don't want to see the test. The material I will use in this experiment is PLA, because it is the most popular, most common material. I know I get a lot of suggestions to try PETG, ABS, ASA, nylon, and believe me, I will do it. The test is in preparation, but it will be represented in one of my next videos. In that video I used my own weight, so I was limited with the maximum load. But now with this new setup, I have the 1 ton chain hoist, and I have a 500 kilogram crane scale, so theoretically I should measure up to 500 kilograms, so I hope I can break even these M10 bolts. I'm not sure at this moment, but we'll see. First, let's see quickly how to design these bolts in Fusion 360. I'm starting with a sketch. First I have to create a circle 10 mm in diameter, and I am extruding this to create a cylinder. And next step is the thread. Of course I have to enable that it's modeled. And now next step is very important because I want to try to use it straight after 3D printing. I'm using the press pull tool. In my case it is 0.05 in negative, so it is a little bit smaller. And then I'm adding the head. This size is 70 mm in M10 bolt, and I'm extruding this surface. And one important thing I want to do to add a cone at the end of this bolt. First I'm creating this line under 45-degree angle, and actually this triangle, and I'm using the revolve tool around the center of the bolt, and this cone will be removed. It will be much easier to start to screw in the bolt. And this M10 bolt is ready. Now the first version is just use this surface to split the bolt into equal half pieces. They're not equal, so you cannot use the first side 2 times. And then the second method is to use the press pull tool just below the minor diameter, and I'm using this surface to cut the bolt. And we have that very nice surface to start the printing. So this is the second version. And the third version to do the same on the other side. Theoretically this should have equal symmetrical load in case of the pure pulling force. We will see. And pay attention, if you are inserting McMaster car component to create a bolt or a screw nut, by default there is no clearance at all. And if you are using the thread command from Fusion 360, in that case some clearance between bolt and screw nut will be already created. So in my case I'm adding additional clearance of 0.05 millimeter, but this is something you have to experiment for your printer. In slicing software I used 100% infill, but with maximum number of the walls or perimeters or shell in the Cura. I noticed that if I print M6 bolts with a 0.15 millimeter layer height, I get much better thread, and then I don't need to clear them with the die or tap tool. And of course I try to screw the nuts straight from the 3D printer with vertical bolts. I didn't have any problems. And also I tried with other bolts, and that additional clearance worked fine. So even with these horizontally printed bolts with supports, I could screw on the nut without problem. I had to force it a little bit first time, but then it was okay. I will explain that later. And these are M6 bolts. And as I mentioned, I get better quality when I printed with 0.15 layer height. It is printed in horizontal position. Well, here I always had a lot of problems. That's why I don't like the supports with the bolts. It was very hard to force the screw nut on the thread. And here they are. Let's analyze them a little bit better. So I have M10, M8 and M6 bolts, and I have three pieces from each type for these three tests: the tensile, shear and torque test. Let's start with the M10 because it's easier to explain. These are printed in vertical position just for reference, and of course they are perfect straight from the 3D printer without any post-processing or modification. The horizontal arm are much stronger. And with that clearance reduction, I can use it with the nut without any modification. There is very ugly line where I remove the supports. But if I force once this M10 nut on it, it can work perfectly, and this is the strongest. And here is the socket for the wrench. Works perfect. Now, as I mentioned, the biggest problem with this is that we have to print it with the supports. Then I get a lot of suggestions. Print them in a half and use them with a nut. Here they are. Be careful, I mark them because it's not equal. You cannot print two this side and then use it together, because they will not, this surface will not align perfectly. And screw the nut on the other side. And it can work without even gluing these two pieces together. Okay, then another idea I got from commenters is to slice the bolt from two sides. And of course, the nut goes on it without any problem. But what is the problem with this is the head. As you can see, it works like open-end wrench. And I hope the torque will be big enough to transmit the torque before I break the screw itself, because the purpose of this head is to be strong enough, stronger than the bolt itself. And of course the last method is this one. When I sliced the bolt only on one side, the disadvantage of this compared to the other one, that the load it will not be symmetrical if you pull it, and maybe there will be some bending, and maybe it will be easier break. We will see in test. And of course it works perfectly because it doesn't need a support, and I really like that now it has almost full-size head, only on the one side is sliced, and I believe that this will be strong enough to transmit the torque big enough to be stronger than the bolt itself. but we will see in the torque test. Quick analyzing of the M8, the same thing, all bolts are ready to use straight from the 3D printer. And now just a few words about M6 bolts. I noticed if I print it with 0.15 layer height instead of 0.2, then I have much better precise threads. So this one is sliced only on one side. And it works perfectly straight from the 3D printer, because I don't have supports here. For some M6 bolts I had to use the die tool for cleaning the thread. And now it's time for testing, and I'm starting with a pulling or tensile test. M10 bolts, and each broke near the head. And now M8. M8 vertical. M8 bolts, and now M6. Most of them broke where the head is, except these printed in vertical position, probably somewhere was the weakest layer. Here you can see the results of the pulling test. Here is the graph with these results, and I'm very happy with them because these new methods are not much weaker compared to the horizontally printed bolts, and actually here we don't need support, and they are much stronger compared to the vertically printed bolt. I hope something similar will be with the shear stress. It's time for shear stress. So here I have holes for M10, M8 and M6, and on this side I have a thread. Usually I use a nut on the other side, but when it breaks, sometimes I lose the nut. So this is not comparable with my previous videos test for shear stress, but here in this test each will be equal. And these are the results for the shear stress. And the good news, the new methods has the same strength as the horizontally printed bolt. I hope the result will be similar with the torque test too. Let's start with the M10, printed in vertical position. And this will be only a washer. And I will start tightening, and it always measures the peak of one movement, so probably it will be visible. Horizontal position. This should be the strongest. So 5.9 was the peak. .7, and this is what I like. The head survived, so it worked like a normal bolt. And now the most critical, so this is the size of the M10 wrench. We will see if the bolt will be stronger, the cylindrical part or the head. .9, not bad. And take it out. And now M8. 2.0. This horizontally printed didn't broke, but the thread is shared. 0.7. Again, very critical type of the head. 1.7, 1.9. And now M60. Very big layer. Okay. 0.7, 0.8, 0.5. spliced on two sides. It has a little bit different head. 0.4, 0.4. So these are M10, M8 and M6 bolts. Interesting that M10 bolts usually broke, and that's how the bolt should act if overload. But the M8 and M6, the thread was sheared instead of breaking, except these, of course, printed in vertical position. And these are the results of the torque test in Newton meters. This value is actually below the range, 0.3, so I don't know the exact value. And here you can see the graph, and there is not a big difference from vertically printed bolt, but I'm happy with the results. After my first experiment where I found out that horizontally printed bolt is so much stronger compared to the vertically printed one, I was very sad because in that case I have to use the supports, and sometimes I need a die tool to clear the thread. But now I have three new methods which are just a little bit weaker compared to the horizontally printed bolt. And which one from these three? Well, that printed in two halves is not so comfortable for using. And also there is no need to cut the bolt from two sides. So my favorite new method is this. Sliced only on one side. And it can be cut almost on minor diameter. First I thought it will be too big overhang for start the printing on this diameter, but actually I noticed that it will be printed with the bridging from the threads. If you are still watching this, maybe you notice there are no ads during the video. For exchange I need a small favor from you. No, not to subscribe, but help me answering all those comments which I probably get where to use 3D printed bolts when you can buy a metallic versions. Maybe you can leave me a comment where do you use 3D printed bolts. Well, that would be it from my side. I hope these informations were useful to you too. Thank you for watching, and happy printing!